Champions, I'm so excited. I just can't hide it. I'm about to lose control and I think I like it. Just like this output stage did when the control grid line, or the input, looks like it's shorted to one of the screen grid resistors, which I'll show you in a close-up. There you go. There you go, champions. Look at that. Clear image zoom. Thank you, Sony. So what I think's happened is the HT on the resistor body, which had lost its enamel in that area, has melted and shorted, probably due to very high output, possibly through a attenuator, has shorted to that wire by melting the insulation. So that has destroyed those two valves on that side. You can see there the enamel just flakes off, even a bit rusty. So I reckon that's what's caused this failure. Now, as you saw in the previous, the Super Lead 2203 converted video, the last video to go up, I don't like the way that they mount these resistors. They're just hanging onto the socket and you got this wire free floating, free balling around there. And that has come in contact with the screen grid resistor, which was very hot. Like I say, probably from being driven very hard. So like I showed on the previous video, I like to put tag strips here and mount those resistors to those like little one terminal tag strips and then run the wire to that. So nothing in this area can shift around. It's all bang where you put it, secured with hardware to the chassis. In this case, I think I'll just redo this. Those resistors have pretty thick leads, but we'll just position it plenty of room away from the screen grid resistor. We'll float that up directly above or below the socket, as it were, since the chassis is inverted. Now up this end, I was scratching my head a while there. I know it does happen, that's probably why I'm bald, as to what they've done with the input circuitry. So you got your high gain input, just probing with the continuity down on the tip of the jack there, and it goes to this green wire, goes to that grid stopper. And there's a trace under here which has been cut, but it doesn't go anywhere anyway. So I don't know why they've done that, but it's got continuity from that side of the grid stopper to the input of the high gain triode, so the first triode. So I'm trying to figure out where's this green wire go. There's nothing attached, and I looked under the board and it's actually tack soldered to the bottom of this resistor lead. So no idea why they did it like that. So I'll be pulling that out, and for lower noise and more stability, I'll be scraping away that toothpaste looking stuff there, which comes from the factory, and removing that green wire, removing this wire, just disconnecting that grid stopper there, running a bit of coax underneath all the way to that grid pin there, and putting the grid stopper directly on that pin as close as possible to the valve socket. So that will aid with stability and it'll be less susceptible to noise as well. That's the way to do it. Now, second triode, not as critical because it doesn't have it's not another gain stage after it, so we probably could just leave the unshielded wire there. We'll see how that goes, but it's a bit silly that they've wired stuff to, you know, resistor footprints and whatever, when you could just run a wire directly over there and possibly coax that as well. So that should help with the noise floor, as well as like I say, high frequency stability, preventing oscillation, that kind of thing. Now down here it's got the original bright cap still. I'm not a huge fan of having both bright caps installed, that one there and the one on the divider there, but that is the sound of this amp. It's just very shrill unless you crank it up all the way. If you're cranking the gain all the way, that's out of circuit anyway, because it's bypassed by the pot. So a lot of people will like having a bright cap there, but then you ask them, you know, you see the settings and they always have the gain maxed out. So it's like, well, why even bother having a bright cap? To me, at lower gain, it just makes it extremely shrill. And with some speakers like G12 T75s, it can be a little bit much. But again, tone is a taste thing. Some people like it bright, some people don't. Alright, champions, we're up and running. We're sitting at around 40% bias, so I'm going to have to just maybe parallel a resistor with that, oh, wrong one. With that 56k there. It says 47k on the board, but that looks like a stock resistor, so I left it in. You never quite know, particularly when you're putting a new set of valves in, whether the range is going to be bang on or not. So it's just something I adjust. I'd give it a power up and quick test. So we'll probably put like 100k in parallel with that one, because that's maxed out, and we're only hitting 40% there on the EL34s. So I ended up doing a couple of things I wasn't going to do, like mounting the grid stoppers down there on little tags. See, they're mechanically secured to the socket screw, and we've reused the grid stoppers there because they all measured within tolerance. And the leads were adequate condition and length. But yeah, we just got 4 individual tags there, 1 for each grid stopper, and that way nothing there's going to move, and nothing's going to hit the screen grid resistors like it did on the stock setup. All right, so same as last time, we've bunched together all the unused primary there, and we've spliced together the wire that operates the neon down there at 120 volts, because that's a 120 volt neon. 125 it says there. So yeah, that's wired to the 110, I think, tap. Got all our new filter caps in there. Nice tube amp Doctor 50 microfarad 500 volt dual sections. 2 nice shiny new V-shays down there for the bias supply. Everything up the back on the preamp valves was pretty much untouched. The only thing I did do was add some coax there to both the triodes there on V1, and mounted the grid stopper down there. You can see under the heat shrink there's a grid stopper directly on the valve socket, so we bypassed all the stuff on the board and removed those wires as a result. Now I've redone a bit of stuff on the output valves. We didn't redo the whole lot, but I chucked some heater balance resistors there and removed lifted the center tap, bunched it up with those wires there. That just helps a bit with the noise. Just so if something does fail in a high voltage to heater circuit mode, they'll just go open circuit instead of causing chaos in your power transformer. Just cleaned up the wiring a bit in this area. There is quite a lot going on in the back of these amps, so you've got your speaker and everything right there, so they do look pretty busy at the best of times, but we just cleaned it up as best we could. I did reuse that IEC thing. I just made very careful sure that the leads were properly prepared and just not over tightened or under tightened. It's pretty critical that you get it right, so I just use a smaller diameter screwdriver so you're not subconsciously cinching the hell out of the thing. Alright, so we'll run over the improved ground scheme again. Starting from the preamp end, we've got a hole drilled down there for all the preamp grounds, and I've just done the same thing I did on the last one, where I've just created a short little ground bus there between the 2 volumes. The only other ground needed on the front panel is for the middle control attached to the preamp node, and then on the phase inverter node I ground the bias supply and the tail of the phase inverter, also otherwise known as the presence pot. That is a 22k with a 100 nano. Lyle commented in the last one that the 5k pot was a bit silly. I left that one in the last one just to see what the difference was, because I haven't really experimented with that up to this point. And it was acceptable, but yeah, probably should have changed the pot in that one. We can always revisit that if the customer's got any issues with the way it sounds. Reuse the balance resistors there. They also double duty as like a bleeder resistor, providing the standby switch isn't switched off, because that breaks the circuit between that and the B+. You know what, champions? Quick correction. That standby switch actually turns on and off the AC. Silly me. I was looking at the schematic of another version where it's just a single, well, they're only using one half of the switch. But this one's actually the preferred type, where you're switching off the AC. So that's easier on the switch, even though it's got the high voltage across it, because at 100 times a second that passes through 0, so it's easier to break the arc. So yeah, that is the preferred way of doing it. And that also means I just noticed that when I was in standby mode, there's no voltage on the reservoir there. So of course there wouldn't be, because it's not in circuit yet. I just don't want to give you a bum steer, champions, because you know what it's like. You do all the errata and stuff in the description of the video that no one reads, and you just get 50,000 comments about, well, I wish, maybe 5 comments about all my mistakes. It's pretty often that people don't comment if everything's correct, but they only comment when things are wrong, and that's known as Cunningham's law, apparently. And down there we've got our phase inverter node. So that's grounded. You can see the little black wire disappearing under there. That's grounded down here to the phase inverter ground. And you've got your screen node there, which is grounded to the cathodes of the output valves. I've removed those 3 watt 1 ohm resistors, partially because I don't use them for measuring anything, and they got in the way, and I like to steer my grounds a little bit more accurately than just to each socket. And I don't like having the resistance between that valve socket and the chassis, which is often not zero. I've got to tell you, champions, since I got this thing, it's really enlightening to know that ground ain't ground. So see these weird probes with the two conductors on each, the positive and negative. So this is what they call 4-wire Kelvin. So there's actually 2 wires running down each lead, and the meter internally compensates for the lead resistance and its variation with temperature. Not only that, but once it's done all of that, if I go on to 4-wire ohms mode and I touch the leads together and then I hit null, that's pretty damn accurate, and you can actually pick up a lot of dodgy connections and dodgy grounds just using this method. It's quite enlightening, champions. So the principle behind this grounding is to keep the dirty, well, basically the pulses, the massive pulses from the transformer AC cycles into the reservoir cap, isolated to its own ground. So here we've got its own ground. Don't worry about that green wire. That's just a electrostatic shield within the transformer. It's got no other connection. You just ground them. And down here, that black wire goes up to the rectifier ground. So that's keeping all those horrible dirty pulses out of the rest of the circuit, which greatly improves the noise floor of these things instead of having all those return currents running through the chassis itself, because a chassis is not a 0 ohm resistor. It has slight resistances in it which allows fluctuations and currents to flow in it into other circuits, I should say. But yeah, there's a lot of theory in there, and grounding is a pretty complex subject, so you know, we could make a whole video on that. Maybe we should, but like I said in the last one, Lyle's got a pretty good detailed video on it, and he is definitely much more succinct at describing things than I am, being an English major. See, I can't even say the word English without stuttering. God. Alright, so just with the 100k resistor across the 56k, that's brought us back to about 42% at the lowest setting. And we should be able to adjust that to a pretty good range, somewhere between 55 and 60%. I'll go about 55, depending on the mains voltage. So sound-wise, it's sounding really good. The customer kind of didn't want any mods to this, and to be honest, I don't think it really needs it. I'm pretty happy with the way it sounds from a rock point of view. If you was playing heavier styles, you might want to put a drive pedal into the front, or a clean boost into the front, or think about maybe a FET boost board add-on, or possibly some modifications to the existing circuit just to get a bit more drive out of it. But for the Aussie pub rock thing, it sounds perfect, and it pushes into like punk and all that kind of stuff as well. So very nice amps. I love these things, and even in their stock form, they're a lot of fun. So I'm going to cut this one off here, try and make it a quickie, and just do some quick sound samples for you legends. So I'll see you there. Alright, legends, this took a surprisingly long time just to do everything right and redo all the connections that I wasn't happy with. But, you know, I really enjoy making these things all they can be, and thanks for joining along. I think for the next video we need a bit of a palette cleanser though. We've been in sort of Marshalltown for the most of 2026, so time to get on to some more unique and interesting stuff. So, thanks for watching. Of course, if you're not subscribed, you should. So, you know, I would suggest you do that. Like, not as a threat or anything, but, you know, if you know what's good for you. I do know where you live. Yeah, hit that subscribe and give me a thumbs up, of course. Unless you hated it, of course, in which case you should give me a crash course in pedantry and leave all your snarky comments below. Because either way, it's engagement, legends. The old algorithm feeds on hate just as much as love. Anyway, see you on the next one. Change your bed sheets, moisturize your elbows, drink lots of water, and try to go see a local band. Your life will be better.